Good afternoon, everyone. My name is Anders. I'm an engineer on the Safari and WebKit team, and I'll be joined later by my colleague Beth. And this session is session 206, introducing the modern WebKit API. We've got a lot of really cool things to show you, so let's get started. So first, I think I want to give you a brief overview of what WebKit actually is. One way you can think of it is that WebKit is the layout and rendering engine behind Safari on Mac and iOS. So WebKit parses and renders HTML, it loads and displays images, it runs JavaScript, and so forth. Another way to look at it is that WebKit starts where the Safari user interface ends. But WebKit is also used by a lot of other apps, such as Mail for displaying rich HTML email, and iBooks for rendering gorgeous ebooks, and even applications you wouldn't normally think were using WebKit, like Messages for its conversation view. And of course, most important of all, your apps. You've done some really amazing things with WebKit. So if you're using WebKit in your app today, on iOS, you're using UI WebView. So let's have a quick show of hands. How many of you are using UI WebView in an app today? Wow. On OS 10, you would be using a WebView. And how many of you are using a WebView? Cool. Now, over the years, we've received a lot of requests from you, especially on iOS, for something a bit more powerful. And we really think we have something that you're going to like, and that is the modern WebKit API. So what are you going to learn today? You'll see how to adopt the modern WebKit API and to use it in your app. We'll take a look at a few new cool features and how to integrate those in your app. And then we'll dive a bit deeper, and you can see how you can customize the way WebKit loads web pages and even customize the web content itself. So the modern WebKit API. Class for class, this API is exactly the same on iOS and OS 10. Yeah, that's pretty cool. Of course, there are some minor changes due to the way we hook into AppKit and UIKit, but it's pretty much the same. We're also taking advantage of the latest and greatest language and Cocoa features, so you can spend less time writing glue code and more time focusing on making your app great. And we've tried really hard to reduce the surface area while still giving you access to a ton of cool features. And we're using the multi-process architecture that we're also using in Safari on both OS 10 since Lion, and now on iOS with iOS 8. In fact, one of the goals we had with this modern API was to take a lot of features that were previously only available to Safari and give you access to them. For example, super smooth 60 frames per second scrolling using hardware acceleration and core animation. The full power of the JavaScript Nitro engine on both OS 10 and iOS. And this includes the fourth-tier LLVM-based compiler that Greg was telling you about yesterday. We've taken the back-forward swipes and the pinch-to-zoom gestures from Safari and built them right into WebKit. And we have a really cool way for your app to talk to web pages and vice versa. Now, I mentioned that WebKit is multi-process. And what does this really mean? It means that web content runs in a separate process completely isolated from your app, like this. Now, why is this a good idea? Well, it's great for responsiveness. Let's say you have loaded a web page, and the web page is running a lot of scripts and doing a lot of layout. Your app will still stay responsive even if this happens. And if you've loaded a web page that is creating a lot of JavaScript objects and using a lot of memory, we'll make sure to handle that gracefully instead of having your app be jettisoned. It's also really good for battery life and power usage. Since each web page runs separately in its own process, we can put individual web pages into a low power mode for things like background tabs and fully occluded windows. Now, this is all completely transparent to you. When you create a WK web view, that is our new web view class in the modern API, we'll spin up a web content process. When you create another WK web view, we'll spin up another web content process. Now, we do this up to a limit, and then when you create more WK web views, they'll share the web content processes. And when you deallocate your WK web views, we tear down the processes for you, and you don't have to worry about a thing. So let's talk about how to adopt the modern WebKit API. So Beth and I are both huge Wikipedia fans. We love reading Wikipedia. We read it all the time. And so we figured it would be a kind of cool idea to write a dedicated Wikipedia browser app using the modern API. This is what it looks like. It's called Wkipedia. Now, if you think this is just a WK web view inside an NS window, you're absolutely right. But don't worry, we're going to add some more features to it. But how did we create this WK web view, and how did we load the web page? Well, creating a WK web view is really easy. Just as with any other view, you call alloc, and then you call init with frame, and that's it. And how do you load a web page? You get the URL, you get the URL request, and then you call WK web view load request, and that'll load the web page for you. So that's all good if you have an app with a single web view. But for Wkipedia, we really want to support multiple windows, so you can have more than one article showing at once. And when you do this, there's always some states that you want to share between your web views, such as preferences, the set of processes to create your web pages in, and visited links. And the way to do this is to create a single configuration object, and then when you create your WK web views, you pass along the configuration, and that will ensure that all the state is correctly shared between those web views. This is what it looks like in code. First, you create your WK web view configuration, and then you create a WK web view, but you use init with frame configuration, and you give it a configuration. And that's all you have to do. OK, back to Wkipedia. Now, even though this is not going to be a full-fledged browser, there are still some browser-like features that we want to add, such as a back-forward button, a title, and a progress indicator. So let's take a look at how we would do this. And let's go from left to right and start with the back-forward buttons. For this, we have a bunch of action methods on WK Web View. Here are some of them. You can hook these up in Interface Builder to your UI elements without having to write any code. And so for Wkipedia, the ones we're interested in are go back and go forward. And these are also auto-validating, which means that when you have hooked these up to your UI, it'll automatically update the enable-disable state based on whether you can go back or forward. So you don't have to worry about that. So what about the title and the progress indicator? For that, we have a bunch of properties on WK WebView. Here are some of them. These are COCO key value observing compliant, which means that you can use the normal COCO KVO methods to listen for any changes to the property values. And if you're on OS 10, you can use COCO bindings to hook them up to your UI without having to write a single line of code. So for Wikipedia, we are interested in the page title, just the title property, and whether the page is loading or not, and that's the loading property. Okay, so Wikipedia is really starting to come along here, but it's still not a dedicated Wikipedia browser. Now, what do I mean by that? Well, let's say you go to the WebKit article in Wikipedia, and you click this link to the WebKit homepage. That'll open the link inside the Wikipedia browser, but we want this to be a dedicated Wikipedia app, and we don't want to load any external links. So what we want to do is customize the way pages are loaded. But before I can tell you about that, I need to explain how page loading actually works in WebKit. So first, something happens that triggers a page load. This can be one of many things. For example, the user clicking a link or using the back-forward buttons. It could be JavaScript setting the window.location property. Or it could be a subframe loading, because subframes and frames are just documents inside of each other. And as we saw earlier, it could be you calling WK WebView load request. Then we send a request off to the server, and we get back a response. This could be a positive response, or the server could send back a 404, which means, sorry, I don't know what this resource is, file not found. And then the server sends back some data, and we're done. Now, what you can do with WebKit is to have your app sort of inject itself after the action and response phases, and to decide whether to continue the load or whether to cancel it. And the way you do this is by implementing methods on the WK WebView's navigation delegate. There are two methods that correspond to the two different phases. The first one is decide policy for navigation action for the action phase. The second one is decide policy for navigation response for the response phase. And with both of these delegate methods, you get data objects that contain enough information for you to be able to make an informed decision about whether you want to continue the load or not. So for decide policy for navigation action, that object is a WK navigation action object. It has properties. For example, the navigation type lets you find out which type of navigation actually started the load, like if it was a link being clicked or if it was a go back, go forward request, and so forth. Request is the request that we're going to send to the server. And with the modifier flags property, you can even tell if the user held down Shift or Command or Option when clicking the link. For decide policy for navigation response, you get a WK navigation response object. This also has some properties. Response is the HTTP response that we get back from the server. And in addition to these data objects, you also get a decision handler in the form of a block. This is how your app can decide whether you want to go through with a load or cancel it. And you do this by calling the block with one of two values. So for decide policy for navigation action, you either pass WK navigation action policy cancel or allow. And for decide policy for navigation response, you pass either WK navigation response policy cancel or allow. Now, you can either call these blocks right away, or you can call them sometimes later, which can be really useful if you want to put up some UI and let the user decide whether the load should continue or not. So now I'd like to ask my colleague Beth up on stage to show Wikipedia and how to add some of these features. Beth?
Hi, everyone. I'm Beth Dakin. Anders and I work together on Safari and WebKit, but lately we've been working on our pet project, Wikipedia. So I have a super bare bones version of the app to show you, and together we'll use all of the information that Anders just gave us to build it up and turn it into a dedicated browsing app. All right. So I'll show you what we have, and then we'll work on improving it. Just going to build and run. Here we go. This is Wikipedia as it stands. It's really just a WK web view in a window. We get all of the great WK web view features, super fast scrolling. We get the super fast JavaScript engine with the 4th tier LLVM just-in-time compiler. Can click on links, navigate to new pages. So that's great, but I'm clearly missing some basic browsing features. If I look at the same website in Safari, for example, if I click on a new link, then I get some progress indication at the top for indicating how the load's going. The URL bar gives me some indication of what page I'm on. I can go back. These are things that we clearly want in our app for it to feel like a web browser. So let's add them. I'll give you a quick tour of the code first. This is our main class. It's a browser window controller, and that's an NS window controller. And if we look at the implementation file, you'll see this is where we have a property for the WK web view. And down here in window did load, this is where we allocate our web view, and it's where we load our initial request. Okay, but we want to add some toolbar items, so let's go into Interface Builder. All right, need to get my toolbar here. There we go. First, I want to make the toolbar visible at launch, and then we'll double-click it to start adding some items. So first, we wanted a back and forward button, so I will drag those in. Hide this. And if we go over to this panel here, let me highlight one of these buttons. Here, I'll zoom this up for you. You can see I've already hooked these buttons up to the appropriate method. So the back button's already hooked up to the go back action method, and the forward button's already hooked up to go forward. So those should work. Then we want some indication of the page that we're on. So we don't want a URL field here because we want this to be a dedicated browser app. We don't want people to type in random URLs. They'll use the search field in Wikipedia to get to different pages. So we just want some text, but we want it to reflect the title of the Wikipedia page that we're actually on. So that's very easy. Over here, let me zoom this up again. So for this text, we just want to bind it to the file's owner, which is that browser window controller class that I showed you a minute ago. And then we want to set the model key path to webview.title. And so that's one of those KVO compliant properties on WebView, WK WebView that Anders was telling us about. So this should be all that we have to do. This should automatically update whenever the title value changes. Just get all of that KVO goodness. All right, and finally, we just want some progress indication. So I'll drag in the spinner too. Okay, that looks about right. So let's see how that works. Let's build and run. Okay, so we have some progress here. I'll zoom up a little. We have back forward buttons. Great, we'll see if they work in a second. We have a title that reflects the page that we're on, San Francisco. Our spinner doesn't seem to be doing quite the right thing. It's just kind of always there, and it's not indicating any load progress yet. So if I navigate to a new page, great, the title updated right away to reflect San Diego. Click my back button, and we went back. Awesome. Forward. Great. Okay, so we've made a lot of improvements. We need to fix that spinner. I also feel like this titles is really long and unnecessary. They all seem to have this suffix, Wikipedia, the free encyclopedia. I think it would be more useful in our app if we truncated the title down just to be the beginning part. So we can handle that very easily in Interface Builder as well. So let's make those two fixes. First, let's fix that spinner. To fix that, we want to go over here again to this panel, to the animation section, and we want to bind to the file's owner again. Again, that's our browser window controller class. And here the model key path will be webview.loading. Yes. And again, that's one of those KVO compliant properties. That should be all we have to do to get this to animate whenever webview.loading is true. There's one other thing I want to do with this, though, which is over here, I want to uncheck display when stopped. So then it should go away when it's not animating. Okay, and now we want to truncate that title also. So I did already write some code that would do that down here. If we look in here. So this was just some simple code that I wrote that would take an NS string and see if it had this as a suffix at the end, and then return a string that doesn't have that part. So I already wrote some code to do that, and I can invoke it from within Interface Builder right over here using the value transformer option. Delete Wikipedia title snippet value transformer. So that will take the title and invoke this method with the title, and then the result will be what's reflected in the toolbar. So let's save, build and run again. Okay, so progress has been made. Let's try clicking another link. We get our spinner, it's animating, it goes away when we're gone. Our title is now a much smaller, more useful thing for our app. We still have our back forward buttons. This is looking great. This is really feeling like a browser. But I haven't done anything yet to make it a dedicated Wikipedia browser besides just not providing URL fields. But if I go to a link like this and click on it, it's going to still open right in my app, which is not the behavior that I'm looking for. That sort of defeats the purpose of this being a dedicated Wikipedia browsing app. So we can easily fix this by implementing the navigation delegate, just like Anders taught us. So let's do that right now. Let's go back to the code. Okay, so first, I want to add one line of code to window did load here to set the navigation delegate. Here I'm setting the navigation delegate to self, so this way WebKit will know to look here in my class to see if there's any implementations of these delegate methods. And then we want to implement one of the two delegate methods. We want to implement decide policy for navigation action. So let's quickly step through this. So first I want to get the URL that the app wants to navigate to. And then if the host URL does not have a wikipedia.org suffix, so this is a non-Wikipedia link, then in that case, I want to pass this navigation off to the default browser on the system. So that's what will happen with this line of code. Safari should open that link instead. But we still need to tell our WK WebView that it shouldn't go ahead with the navigation also, so we'll invoke the decision handler block with the WK navigation action policy cancel value. And while we were here, I thought it would be cool just to add a feature to command click a link and open it in a new window in my own app. So that's what I added down here. So first I'm finding out if this navigation is happening with the command key down. And if it is, then I'm going to create a brand new browser window controller, and I'm giving that this navigation request. And then again, since I don't want this WK WebView to also navigate to the new page, I invoke the decision handler block with the cancel value. And otherwise, if we didn't fall into any of those situations, then we'll invoke the decision handler block with allow. So let's save and build and run. Okay, great. So regular page loading still works, so that's good. Let's see. Let's click on this link. And awesome. We successfully handed that navigation off to the default browser. And if I command click a link, I get it in a new window in my own app. Each of these are in its own process because this is Modern WebKit API. Pretty cool. So this is awesome. In just a few minutes, we've built up a dedicated browser app using the Modern WebKit API. But I still feel like there are a few modern features that I'm lacking here. For example, again, if we look back in Safari, who really uses the back button anymore? I mean, I typically use the swipe back gesture to go back, and I also want to be able to double tap to zoom and pinch out. If I try to do those things in my app, nothing happens. Double tap. No, nothing's happening. But it's really, really easy to add these features. So I'm going to do it really quickly, even though Anders hasn't showed us how to do it quite yet. But we just need to add 2 lines of code. Back up here in window did load. Okay, so this first line of code allows back-forward navigation gestures. Set that to yes. That gets you the back-forward swiping. And allows magnification. That'll get double tap and pinch to zoom. Save that, build and run. Okay, so now if I go forward, should be able to swipe back. Awesome. Can double tap, pinch right out. Awesome. So there you have it. We've built a modern we've used the Modern WebKit API to build a dedicated Wikipedia browser app with modern feeling features in just a few minutes. So I'm going to hand it back to Anders. He's going to teach you a lot of the more advanced features that you can do with this API. And I'll be back up later to show you how you can integrate some of those features into our iPad version of WKpedia. Back to you, Anders.
Thanks, Beth. That was really cool. I especially like the extra touch at the end where you added the gesture support. Let's recap how Beth did that. So for the navigation gestures, that's the swipe to go back and forward. You just set the allows back forward navigation gestures property to yes on your WK WebView. For zoom gestures on OS 10, you set the allows magnification property to yes. On iOS, this is handled by the underlying UI scroll view, and it's already on by default, so you don't have to do a thing. So let's talk about WKpedia for iPad. This is what it looks like. It's really great. I use it all the time for reading Wikipedia articles on my way to work. But I've noticed something that bothers me a little. See, I like to read certain sections of an article. And that means that I have to go find the table of contents. I have to scroll down to it. I find a section that I want to read. I tap on that link. And then when I've read it, I need to scroll all the way back up or swipe back and look for another section and read that. So I told Beth about this, and she said, well, why don't we use some of the more advanced features of the Modern WebKit API to take care of this? Like, why don't we just get rid of the table of contents from the web page? And while we're at it, we can also get rid of this sidebar to the left to make more room for the article. And then we can put the table of contents natively in the UI. So we have this little button in the top left corner, and when you tap it, you get the table of contents in a native UI table view. And when you're in landscape mode, you can always have it visible because of the extra space. So what we really want to do here is customize web page contents from WKpedia. And we want to use 2 features to do this. One is called user scripts. The other one is called script messages. These are both handled by an object called WK User Content Controller. WK User Content Controller is part of the configuration. So it's a property on the WK WebView configuration called User Content Controller. So let's talk about user scripts. User scripts are a way for you, app developers, to take some JavaScript and inject it into the web page and then have it do something. This will happen automatically for every web page, so you don't have to manually call it every time the page loads. So when you add a user script, you need to consider two things. The first one is when you want your user script to run. You can either run your user script at document start time. This is right after the document element has been created, but before any of the document has been parsed. Or you can run them at document end, which is after the document is finished parsing, but before any sub-resources such as images have necessarily finished loading. This corresponds to the DOM content loaded event. You also want to consider where these scripts should run. You can run them either for all frames, so both the main frame and the subframes, or just for the mainframe only. So how do you create a user script? First, you get the script string from somewhere. In my case, I just have it as a string literal in my code. Then you create a WK user script object and pass it the source code. And here I've highlighted the when and where. So we want this user script to run at document start time, but only for the mainframe. And then you tell the user content controller to go ahead and add the user scripts. And that's it. Now, what can user scripts do? User scripts can do anything that scripts running on the web page can do. So that includes using the DOM API to change the document structures, adding event listeners for on-load events or click events or keyboard events or any event. You can load external resources like images and even XML HTTP requests. And you can also communicate back to the application. And this is where script messages come in. So script messages are messages that user scripts send to the application. They consist of JSON data, so objects, arrays, strings, etc. When you send them from your web page, we automatically convert them to the corresponding Objective-C types, so NS dictionaries, NS arrays, NS strings, etc. So when you want to listen for script messages in your app, you want to register a script message handler. This involves creating an object that conforms to the WK script message handler protocol. This protocol has one method that you have to implement, did receive script message. And then you tell the user content controller to add the script message handler, and you give it a name. And this name is really important because it is how your web page communicates back to you. So when you've added a script message handler, we expose a window.webkit.messagehandlers.yourname.postMessage function. Here's how you use this postMessage function. You get your message in JSON form from somewhere, and then you call postMessage, and you pass along the message. So on the receiving side, WebKit will call did receive script message on the correct user script message handler, and the body property of the WK script message object that is passed along here will have your message automatically converted. There are also some other properties on WK script message. You can find out which web page posted the message and the name that was used to post the message. One interesting thing about script messages is that it's just not user scripts that can send script messages. Your web page can also send messages. This is really cool if you have a website and an app and you want the website to be able to communicate with your app. But it also means that if you have a generic browser that can load any website, you don't want to blindly trust messages that are posted by these websites. So make sure you do the right message validation and check that the object is of the expected types, and so forth. So now I'd like to ask Beth to come up on stage again and show off Wkipedia for iPad. Beth?
Thanks, Anders. So I'll show you WKpedia for iPad, and then we'll add some user scripts and some script messaging to add these cool new features. Okay, so back into Xcode. So I'm using the same Xcode project for both versions of WKpedia, actually. So I'm just going to close up the OS X version, open iOS code, and switch my scheme to the iOS scheme so that now when I build and run, I'll be building and running for the iPad simulator. All right, so let me show you what we have. All right, here's WKpedia for the iPad. So again, our idea that we want to use user scripts for is we want to hide some of this content. We want to hide the sidebar so that we can maximize the screen space on the smaller screen. And we also want to hide this table of contents section. And then we want to extract all of the data from the table of contents section and put it into a UI table view that we already have in place. So we can do this with two user scripts. First, we will add a user script to hide the things on the page that we want hidden, and then we'll go back and fill in our UI table view with another one. All right, so first I'm going to add a JavaScript file to my project. So I have one here called hide.js. So this is a really simple JavaScript file. First, I'm creating a style element, and I'm appending it into the document. And the style element, I'm giving it just 3 styles. So we used the Safari Web Inspector to look at what the Wikipedia code looks like right now, and we saw that the table of contents that we want to hide has the class name of TOC. So I'm adding another style to that class. I'm setting it to display none, and I'm making that bang important so that it will override any other display styles they have set on it. And the side panel has an ID of MW panel, so I'm setting that to display none as well. And finally, I just want to adjust the margin on the content to make sure it fills in that extra area now that the side panel's gone. Okay, so this is the JavaScript that I want my app to invoke. So now we just need to add some code to invoke it. So WebView controller, this is my main class in my iPad version. You'll see this is where, again, we have a property for our WK WebView. Should look awfully familiar. So here I have a currently empty method called add user scripts to content controller. So you can see this is invoked from load view. So, and then it's passing in the WK user content controller, which is a part of the configuration. So Anders mentioned the configuration earlier on in the talk. So user scripts are an example of something that's part of the configuration. So that's an example of why you want your different WK web views to share a configuration, so they all get the user scripts. All right, so let's invoke this script. It's just 3 lines of code. So first we're creating an NS string with the contents of URL hide.js. So we're going to take that file that I just added to the project and turn it into an NS string. Then I'm creating a WK user script object with that string. I'm giving it an injection time of WK script injection time at document start. So this means this script will be injected and it will run right after the document element is created before anything else happens. That's good. That's what I want to happen for this script because I want to make sure those styles are there right away. I don't want the chance for the table of contents in the sidebar to appear and only then does my script run, so then they disappear. That would be terrible. So document start, that's what I want. And yeah, for the mainframe only. Okay, then finally I just need to add the user script to the user content controller. And that should be all I have to do. So let's build and run. And success, the side panel is gone. It's no longer there. We just have the article taking up the full width of the page. And we also have hidden the table of contents section. We go right into the history section. Awesome. So now let's add a second user script to get the data from that table of contents section, put it into our UI table view. So first we'll add a second JavaScript file to our project. So this goes through to that table of contents section. It bundles up all the data we want, puts it into an array, and then it sends it, this is the important part, it sends it as a message back to my app. So let's make sure this code gets invoked, and then I'll show you the code that runs when the JavaScript sends a message back. So back here in my add user scripts to content controller method, I'll add a little bit more code. Okay, I'm creating another NS string with the contents of a URL. This time it's with my fetch.js class. So putting that JavaScript into an NS string, then creating a WK user script with that string. And this one I want to be injected at the document end time. So this time I want to make sure that the DOM has been built up, that it has all of those elements representing the table of contents in it before my script runs. Otherwise, it's not going to find anything. And again, for the mainframe only, I'll add that as a user script. And then this is an important line of code. I need to call this so that the JavaScript can call back into my app. So add script message handler, set it to self, and give it a name, did fetch table of contents. So when the JavaScript calls back into my app, I'll make this a little wider. This is the method that will be called, did receive script message. So what I'm doing in that method is I'm making sure that this is the script that I'm expecting to be calling me, did fetch table of contents. And if so, I'm calling into my UI table view class with a method that I've written there. So I'll show that to you. So here in my UI table view code, I'm just going to make sure that this message body, this is the data that was sent to me straight from the JavaScript, making sure it's an array because that's what I'm expecting. Then I call make entries, which is implemented right up here. And I go through that array and I make sure it's all the data that I'm expecting it to be that I've written my script to send over. It's a string representing the title. It's a URL representing the URL that that title would navigate to so that we can have our app navigate to that URL when the user taps on it. And if I have all of that data like I'm expecting it, I create a table of contents entry and I add it to an array. And then finally back here, this is where I invoked that method. I'm going to tell the table view to reload its data at this point, and then that data should all be in there. Okay. So I've set this all up. Let's see if it works. Let's build and run. So here we are, Wikipedia. Everything's hidden still, great. Contents did not quite work. All right, so I suspect that I have a bug in my JavaScript. And one thing that's really cool is that I can actually inspect all of the web content in my WK web view using the Safari Web Inspector. I can even inspect the user scripts that I've injected, which is pretty cool. But don't worry, only you can do this with your app. Other people won't be able to inspect your app. So let me open the inspector. Let's make sure this happens on all pages. I'll navigate to a new page. Still no table of contents. Okay. So here, if I go over into my resources panel, here, let me zoom this in for you actually. You can see that I have my user scripts over here under the extra script section. So under user script 2, this is the script I want to look at. So I can add a breakpoint there and just reload right in the inspector. All right, let's get rid of that. Okay, let's step through. TOC links. All right, do we get into the loop? We do. Great, we get the text, not text break. Oh, okay. Well, there's the bug. We had 2 breaks in a row, so we never got to the code that added any of this data to an array. So this should be an easy bug to fix now that I've spotted it. So let's go back into Xcode. There she is. All right, let's build and run. Yes. We have our table of contents. So now I have our table of contents. If I click around here, I'll navigate to the right section of the document because I was sure to include that data when I passed it back from the script. And there you have it. So today we've built a dedicated Wikipedia browser app for Mac and for iOS. We've added some advanced features to make our app interact with our web content, and we've done it all with the modern WebKit API. So that's all I have for you. I'll hand it back to Anders now.
Thanks, Beth. Wow, this is really going to make my Wikipedia browsing so much more efficient on my way to work. So, the modern WebKit API, available for iOS 8 and OS 10 Yosemite, same API on both platforms. You get the full JavaScript Nitro engine, including the 4th-tier compiler. It's multi-process, which is great for responsiveness and also for battery life. And with user script and script messages, web pages can talk to your app and vice versa. Now, we've only showed a handful of classes here, but the modern WebKit API has much more to offer. So here's what I want you to do. Adopt the modern WebKit API. If you're thinking of writing a new app, I would strongly consider using the new API. If you already have an app that is using either UI WebView or WebView, don't worry, those APIs are still there, but we are committed to this new API, the modern WebKit API, and some features like faster JavaScript are only going to be available in the new API. And since this is a new API, we would really love to hear what you think about it. So file radars, come to the labs, bring your code, post in the developer forums. If you want to contact our Frameworks Evangelism team, you can do so at this email address. There's more information on WebKit and Safari on the Safari Dev Center. And the modern WebKit API is part of the WebKit open source project, so you can go to webkit.org and check it out. And you can also go to the developer forums and post your questions, and we'll make sure to answer them. Related sessions. If you have an app and a website and you want to make sure they work together, there's a great session this afternoon called Your App, Your Website, and Safari. On Thursday, there's a session about the Web Inspector, and on Friday morning, there's a really interesting session where engineers on the iWork team talk about best practices for sharing code between iOS and OS 10. And thank you very much for coming. Thanks.